We will study to the crystal indices, crystal planes and Miller indices. So, this we have seen the unit cell of the crystal, and this that lattice parameters we have used, that A, B, C, alpha, beta, gamma. So, this unit cell of a crystal can be expressed with this lattice parameter, and you know that repetition of that unit cell is nothing but the crystal structure. So, now apart from the unit cell, we need some other parameters for studying the crystal structure. So, that is basically there are different planes of the crystal and how the planes are defined, how planes are given name. So, that we will see now. So, if we take a unit cell, say cubic unit cell, cubic unit cell. So, these are the faces of unit cell. So, face means these are plane. So, here I can see this is the one plane and this is another plane and this is the third plane. So, other three planes are there back side of this and so just if I see, if I take this one, so this one is a one face. So, this is the face of unit cell. We tell this is a plane of the crystal when you consider that this unit cell or is in a crystal structure where many unit cell are placed together. So, if I go towards the next unit cell, if I go towards the next unit cell, so then this will be continued this side. Right, and similarly, if I consider the opposite faces, okay. So, this is the opposite face of this one and these two are parallel. So, this will be another plane, this will be another plane, and it extended so so these planes, these crystal planes is not unit cell planes. So, in crystal this plane will be extended throughout the crystal. This plane will be extended throughout the crystal. So, then we tell these are crystal planes. So, these two planes are parallel. These two planes are parallel, and if I go, if I can get see if I draw next unit cell, if I draw next unit cell, so this say I think right. So, here, so this is parallel phase. So, you can extend right. So, so these planes are parallel planes, and I can continue from just if I draw the unit cell, and just from opposite face, if I draw the planes, okay. So, all them are parallel. So, these are crystal planes. Here whatever the planes I have drawn, I am showing. So, these planes are basically this is nothing but a set of parallel planes, which are equidistant, in this case, say if it is cubic, of course, this the distance are a, the distance are a. Okay. So, this equidistant parallel planes, it is basically we tell this is one plane, we give one name of these planes. Okay. If I give one name of this plane, so it represents this set of parallel planes which are equidistant from each other, the interplanar distance are same. Okay. So, so this is one set of parallel planes. There are other sets of parallel planes. there are other sets of parallel planes. Okay. So, this and this face opposite faces. So, this also can be one plane. Okay. You extend throughout the crystal. So, this can be another set of parallel planes, and other two faces, this is one face and back side, this on the another face, this one is the another face. Oh, yes. This and this, their opposite face. Okay. So, this can be another planes, another set of parallel planes as similar to this, we can get another sets of parallel planes. So, here itself that a unit cell have 6 faces. So, basically 2 opposite faces, 2 opposite parallel faces. So, 3 pair of oppositely parallel faces. So, this each pair is basically represent a planes, each pair represents a plane. So, here itself from 6 faces we can get 3 planes of the crystal from the face itself. So, what are those 3 planes? How I can differentiate those planes? So, we have to give name. So, for giving name of the planes, crystal planes, so basically an English crystallographer, his name is Miller. So, he introduced a procedure to designate these crystal planes. So, we will discuss this procedure basically in 3 steps. We can achieve the plane's name. So, that is expressed by 3 parameter HKL, and we put in bracket, first bracket. So, then this is called HKL planes. So, how this HKL has come, so that we will discuss. See, by if I take a axis, crystal axis A, B, I think. So, this A, B, and so the C axis, right. Now a plane, if I draw a plane which intersect these three axes, so this is the plane. So this is a plane, this is a plane. I can use. So this is a plane. Say it intersect at A axis, B axis, and C axis. So if I scaled this axis, so this 1A, this 1A, this distance is 1A, so 2A, so it has to be equal distance. So this 3A, this 4A, like this, and this one say one B, 2B, 3B, okay, so B axis, and this one so this 1C, 2C, 3C, 4C, 5C, 6C, right. Okay. So these planes intersect A axis at intersect at intersect at 3A, two B, and 5C. So first step to find out the Miller, so these indices which represent the planes. So first we have to find the intercepts. So these are the now intercepts for these planes. Second step is reciprocal of this coefficient Okay. So this 3 times of A, 2 times of B, 5 times of C. So these are the, so we have to take reciprocal of this. So this is the second step, reciprocal of this coefficient, and third step is simplification. So, we have to simplify this one. So, just this 10 30. So, I can simplify this 10 15 and 6, 10 15 and 6, and there should not be any common factor. So, here there is no common factor. So, this is the simplest that the simplification of this one. So, this basically these are called Miller indices. This is H, this is K, this is L. So, for this plane. So, this planes is called then 10 15 6 planes, 10 15 6 planes. So, this plane is called now 10 15 6 planes. So, this is the HKL planes where the value of H is 10, K is 15 and L is 6. Okay. So, this is the way to find out the Miller indices, and this Miller indices putting in a first bracket is the designation of that planes. So, if this is the procedure to find out the Miller indices which represents the crystal planes. So, let us do exercise. So, what is this plane? What is this? This is a one set of planes. As I told, it represents a single plane. It will carry one name, one Miller indices, one set of Miller indices. So, what will be the Miller indices for these planes? So, for that you have to consider the axis. You have to consider the axis. So, say here let us take the origin O. This is the origin O. Okay. So, then this is one axis, say this is A, this will be another axis, it's B, and this will be the C axis, right. So, if I consider this one, this plane which intersects the axis. So, where it intersects, that we have to find out. So, here I can see these planes intersects. These planes intersects along the A axis here. So, this is basically 1A, and it is parallel to B axis as well as C axis. It will not intersect. So, it will intersect at infinity. It will intersect at infinity. Okay. So, I can write that intersect at infinity. So, infinity B and infinity C along the C, infinity C. C. Okay. So, in this case, what I am getting? I am getting intercepts at 1A, infinity B, infinity C. Then next step, 1 by 1 reciprocal we have to take, 1 by infinity, 1 by infinity, and simplification, that is basically what is giving 1 0 0, putting in bracket. So, this is the planes, its name we can give 1 0 0 planes. Okay. 1 0 0 planes. So, if you consider this next one, so it will cut at 2A, next planes it will cut at 2A and parallel to B and C. So, 2A, so 1 by 2, 1 by infinity, 1 by infinity. So, basically if we simplify, so again it will be 1 0 0. Next parallel planes, it will cut at say 3 A, infinity B, infinity C. So, again if you proceed 1 by 3, so 1 by infinity, 1 by infinity. So, again for after simplification it will give 1 0 0. Okay. So, all planes is basically from this procedure you are getting 1 0 0. That is why I told it the set of parallel planes represents basically one plane, one crystal planes, and that is 1 0 0. So, that unit cell, it has 3 sets of parallel planes. One is this, another is this. So, it cuts at C axis, at 1 C, but parallel to A and B, right, parallel to A and B. So, these sets of parallel planes, it will be cutting at C axis, it will be 0 0 1. It will just follow same procedure for this plane. And so, this and this sets of plane, this one, and this other face is this one. Okay. So, this another set of parallel planes. So, it cuts at B axis, you see, it cuts at B axis at 1B, okay, and parallel to A and C. So, this will give you these planes. So, this is these planes and these planes will be cut at B, means 0 1 0. Okay. So, here itself this, considering the phases of the crystal of this unit cell, we are getting 3 planes, crystal planes. One is 1 0 0, 0 1 0 and 0 0 1. Okay. So, this way we can find our Miller indices, which represent the when this Miller index is put in a first bracket. So, it represents the crystal planes. So, we will continue in next class. So, let me stop here. Thank you very much.